Okay, we need to talk about the reactivity of enamines because they kind of have some special properties. To do that, let's first frame this discussion by just talking about the nucleophilicity of alkenes. So, here's an alkene. This alkene, we know that alkenes they can be nucleophilic, but they are super weak. So therefore, we can only react them with the most electrophilic or electron deficient species out there. Things like really strong acids. So we can protonate an alkene. And tell you what, let's throw in this hydrogen. Now we'll have two hydrogens on that carbon, and we get a carbocation. So we can coax an alkene to react. Takes a little work. We need a really strong electrophile, but it can work. Now, let's look at another alkene, and we're going to change it by putting an oxygen on that alkene. These alkenes, this is called an enol, still a weak nucleophile, but it's made a little bit more nucleophilic because we have this oxygen as an electron withdrawing group, electron donating group on here, and that oxygen has lone pairs that can feed electron density into the double bond. So this really isn't a special case, but this alkene definitely has some reactivity, and in fact it has more reactivity than the simple alkene that we showed in the first example. So we can do this chemistry. Again, let's stick in that hydrogen, make it explicit. And we get to there. And you might say, who cares about that reaction? Well, we actually used something very similar to this when we talked about taking ketones and treating them with bromine under acidic conditions, and we could do alpha halogenations next to carbonyls. And why did this work so well? Well, under acidic conditions, we rapidly established this equilibrium of the enol tautomer, and that enol tautomer, this alkene, with the oxygen attached, was the nucleophile that attacked the bromine. So it's very important chemistry. Okay. Now let's go one step further. Now let's look at this kind of alkene. This is an enamine, which we have recently learned about. And it is, let's call it a moderate nucleophile. Because this is the enamine is a moderate nucleophile, we can actually have moderate electrophiles in here, moderate to weak electrophiles in here to react with the enamine, and we can access actually a lot of different products from this reaction. And so we are going to learn about these reactions, but we understand why is the enamine more reactive? It's because the nitrogen is less electronegative, and it's more willing to share that electron density and push that electron density into the alkene and therefore attack the electrophile. So we're increasing nucleophilicity as we put different atoms on these alkenes. And so the amine is actually a very strong electron donating group, and that makes the alkene more nucleophilic.